look into the data center switching market. I'll cover the product line solution portfolio. I'll talk a little bit about the SDN strategy and moving forward with it, for Lenovo. And at the end, I'll get into near the end rather, I'll get into a deep dive on the system networking product portfolio. And if we have time, what I'd like to do is I've got a demo at the very end that I'll be discussing, and then we'll do a little bit of hands-on as well. All right, so let's get started. So the first couple slides are talking about our strategy and you know, where we come from and whatnot. So as you're well aware by now, the system networking from IBM came over with the x86 business unit from IBM into Lenovo, and as of October 1st of this past year in 2014. We were established in 2003, and we joined Lenovo as Lenovo's premier data center networking provider. We're focused on best-of-breed products for blade center, flex, and top-of-rack switching. We can be leveraged for System X and Think servers to help deliver Ethernet converged storage solutions, which I'll also get into deeper later in this deck. We also bring innovations such as Interconnect, Flex SI Fabric, which will be what I'll be presenting or demoing at the end of the session, and VUG, as well as many others. We have a presence in over 350 of the 500 Fortune 500 companies, providing an open IEEE standard with seamless integration with existing environments. And you'll actually see a little bit about that within the demo. Okay. The data center networking is growing. That's where we're focused. Campus networking is what we're seeing is shrinking. Within data center networking, there are server access switches and core switches. Server access switches is much larger than core and has the highest growth potential. Data center Ethernet switching revenue is shifting to a cloud-based solutions, and that's where most customers are going. Even for the rest of the market, private cloud is growing. Traditional enterprise is shrinking. Okay? SDN is being disruptive, making it an opportunity for networking, for all networking vendors for that matter. Just in a hyperscale went with the ODMs for servers, now they are growing to ODMs or white boxes for switches. Not necessarily moving forward, but that the market segment is growing substantially. All right, so what we're seeing is the adoption of 1 gig and moving over to 10 gig and even 40 gig. Bandwidth requirements are increasing year over year, moving again from 1 gig to 10 gig, and will be crossing over to 40 gig in 2015. The ease of deployment with virtualization and 10 gig virtual NICs for ease of use and management is also being adopted. You should start seeing some new Lenovo channel pricing to match other players in the segments, in the same segments rather, by the end of the year moving into 2015. Okay. All right. So those were the actual product slides, and what I'd like to do now, or rather the marketing slides, and what I'd like to do now is get more technical on you, if you will. All right, so we're finding that customers are looking for more flexibility and the ability to change, scale, and move at a rapid pace. We're also discovering that customers want a vendor that easily works with their existing environments, okay, for interoperability reasons. From hardware and software, they can work independently with one another. And lastly, we're finding that clients are getting tired of paying a big premium for, you know, some of the other vendors out there and want new options and for a new high-volume world. All right, so let's talk about a little bit about, and this is a high-level overview portfolio of our actual some of the products that we offer. So on this particular slide, what you're looking at on the top are some of the flex embedded switches. For instance, the EN2092, which is an all 1 gig, the EN4093, which is basically our bread and butter for the flex chassis, and has the highest volume and the most potential, as it has the most scalable. It's the most scalable product for the actual blade enclosure itself. We also offer SI4093s, and we'll get into that quite a bit more, as well as the Converged network switch that offers both Ethernet and FCOE or fiber channel natively that can run in either NPV mode or a full fabric service mode. All right. From a top-of-rack switch portfolio, we offer 1 gig managed switches, such as the G8052, and I'll get into differences between the 7K and the 8K series in the next slide, or a couple slides coming up. And then we also offer some native 10 gig G8124 and the 10/40 gig 8264, the T series, as well as the CS, which also offers that converged and fiber channel options. And then we have the G8332, which is our new all 40 gig switch that offers up to 32 40 gig ports in a 1U form factor. Okay. All right, so let's look at some of our solution-based options that we can offer within our own in-house portfolio, if you will. The Easy Connect mode, as some of you technical guys may be familiar with, is the Q&Q technology which allows for the transparent switching within either chassis or top of rack and or both. So, for instance, you can have in the picture on the right, you can have the CN4093s that connect up to either a Nexus environment or a G8264 environment or whatever the case may be. And those CNs can be both fiber channel native or NPV mode, and can also be running in utilizing VLAG, which is our virtual link aggregation or VPC, if you will, option that can also be used with Easy Connect. So it allows for both transparency for fiber channel and transparency for Ethernet. Okay. Now, when I say transparency for Ethernet, I don't mean that it's forced up to the top of rack device like you might see in a Nexus 5K, 2K, but it also allows for layer 2 switching that can happen within the chassis. So with the VLAG option, whether you're LACPing or rather port channeling your NICs or not, whether it's in a VMware environment, Hyper-V environment, or standalone, not necessarily standalone, but fixed server environment, all local switching is guaranteed to stay within the chassis. Okay, so that can assist in keeping some of that bandwidth localized to the chassis only. All right. So this Easy Connect mode, if you will, is offered on the EN4093R, the CN4093, and the SI4093. As a matter of fact, the SI4093 is nothing more than the EN4093 that has special firmware straight from the factory that allows for that transparent capability as a plug-and-play device. All 10 of the 10 gig ports externally are enabled as a single port channel. So you can just plug it in, connect it to the network, running in a port channel environment, and you're off and running. All right. As far as the rack switch options that support this capability, it's only the 10 gig switches. The G8124E, the G8264, and the G8264CS offer the same capability for that transparent look and feel, or the mode, if you will. All right. Okay, so another solution from a LAN SAN convergence option provides, again, both Ethernet as a and fiber channel, or FCOE, as a transit device within either the Flex chassis solution or a top-of-rack device like an 8124 or an 8264 that would be connected to or tied to a pair of FCF target switches, in this case the CN4093 for inside the chassis, or the G8264CS that would sit at the top of rack or in an ends-of-row design. And that will directly connect via either a 4 gig or 8 gig fiber channel native in native mode, connect to your SAN target storage device directly, or it can connect right into your existing fabric. Okay? All right, So the last one I'd like to talk about real quick is the Flex Interconnect Fabric solution. This is the one we're going to be demoing, and if you look at the image on the right, I know it's relatively small, but if you look at the image on the right, this is actually what we have set up in the demo that we'll be looking at, and I'll be talking about briefly. All right. So what is it? It's a simple converged Ethernet and FC fabric cluster. Now, I just installed this at one of the customers, and they basically liked it so much they ended up just deploying it at multiple locations. But they didn't use the FC storage part of it because they like native fiber channel all the way to the HVAs on the servers. What they did love about it is that it's a single point of management. Okay, so that might make you think, well, if you're familiar with UCS or the UCS storage, it's very, very similar to that. And that's really that's really the advantage of this environment, or fabric environment, if you will, is that it allows for a single point of management of up to 9 chassis. And that's both Ethernet, and if you desire, they can also support the FCOE capability up to the pair of top-of-rack 8264CSs, which again allows for native fiber channel in either NPV or full fabric mode. And those would be set into a fabric mode to where that is where you actually manage this entire fabric from. Okay, so there's a master and backup portion to those two adjacent devices. All right, it fits in a loop-free design with no spanning tree required. And what I mean by that is that it's literally impossible to create a spanning tree loop. We have special options or special checks, if you will, in the code that say if you cannot enable more than one uplink in the same VLAN to an existing network. Okay, so if you were going to link it up to a Nexus 7K or maybe even a couple of 8264s, those CS switches that sit on the top of the rack within the fabric cannot participate in spanning tree, and it is literally impossible to create a loop to provide you for a loop-free environment, if you will. Okay, it provides for rapid deployment of additional chassis. Now, one of the things that this customer that I was just referring to has recently done is that they added a third chassis. They started with 2, and they just added a third one. And it literally took me 10 minutes to configure the entire chassis to provide Ethernet connectivity into their nodes. After the switches were updated, all I had to do was go into the master fabric switch and add those 2 SI4093s to the fabric. And it's a single command. And then basically you run 2 additional commands to enable the VLAN capability, or VLAN access to the INT ports of those SI4093s. So again, it took once I got the switches upgraded, it took less than 10 minutes to configure the entire chassis for Ethernet connectivity. All right, 95% of reduction in the number of networking devices required to be managed. Again, these SI4093s, you don't manage them. You manage a single device for up to 9 chassis. All right. So given that each chassis would contain 2 SI4093s, if you do the math, it calculates of up to 20 switches to top of rack and 18 internal SI4093s. Zero downtime for service upgrades. That is exciting because never before have we, as far as IBM system networking in a fabric environment, whether it's stacking or fabric or whatever, have been able to offer the zero downtime even when you're doing an upgrade. This option assists with this option of having a staggered upgrade, inline service upgrade. You upgrade the master, it automatically starts upgrading just the SI4093, the first SI4093 in each chassis. Once that's up and stable, it starts with the second. Once those are up and stable, then it starts with the backup CN4093. The backup G8264CS. Then it upgrades the master. So there is no downtime whatsoever when doing a rolling upgrade, if you will. Zero additional flex system capex to implement using the SIs and the 8264CSs. Support for both Ethernet, ISW, and FCOE protocols. And then proven interoperability. with Cisco, Juniper, and there are two modes that you can set the uplinks in. If your Cisco's or Juniper's or whatever the case may be has the ability to do like a VPC or some type of virtual chassis technology, you can, if you look at the picture there, you can essentially see that it's a single virtual port channel running in a full active environment between the pair of virtual switches in the existing environment connecting into the G8264 CSs. Now, if you don't have that capability and it's not an active upstream, then what we can run what's called hotlinks. And what hotlinks does for you is it'll provide a single or a pair of 10 gig connections, or 40 gig if you will, connections from the 8264 CSs to one of the top of rack active devices. The other one will be in a hot standby mode, so that if the active fails for whatever reason, it'll automatically fail over to the slave or to the backup top of rack or core switch. Okay, so we do support both options. Lenovo importance. Lenovo-based design is designed to compete against the HP, Cisco, Dell, and others, and so forth and so on. What we're doing though is we developed this so that we could bring a customer solution to the market that would help the customer manage and be able to troubleshoot from a single pane of glass or a single CLI. Okay. Simplification here really is the name of the game, and connectivity of the Lenovo connectivity of the Lenovo Flex system offerings. Okay, and that is the demo that I'm going to be providing at the end of the session. All right, so just a little bit about the SDN strategy. If you may have been familiar in the past or heard about IBM's SDN VE with VMware and KVM, those products are no longer sold either by IBM or Lenovo. So this may be a first for you. That product is now being integrated into IBM's cloud orchestration, okay, only. It is not being sold as independent switch or independent solutions any longer. All right, so moving forward, the Lenovo strategy is for us to team up with VMware, and we're going to be reselling NSX, okay? And we'll also be supporting the OpenStack Neutron plugin. And if you may have heard, the G8332, given that it's based off of the Broadcom Trident 2 ASIC, has the capability of running in an VXLAN, as a VXLAN gateway, so that we can do the gateway transactions in hardware, okay, for the NSX capability. Okay, some of the dates and times are there. As I said, we are moving in that direction. The managed control for both VMware and vCenter, you can see the dates there. It's roughly Q4 2014, moving into the Q1 and Q2 of 2015 for the different options. Okay. All right, so let's get into the portfolio a little bit. So I'm sure if you've ever been on one of our calls or had essentially anybody speak to you about the Lenovo offerings, or back maybe it was IBM system networking offerings at that point, you've probably been through this grind a few times. So I'm just going to kind of cover this on a high level. So if you look on the right, the in-house offering from Lenovo has a lot of differentiating and value that we can bring to customers, as each one of those switches, except for the one on the left, which is the 1 gig, 48 ports of 1 gig total, with 4 ports of 10 gig for uplink capability. Okay, but the other three, the SI, the EN, and the CN4093, all three of those products can offer up to 64 ports of 10 gig in each of the devices. Now, do you get that when you first order it with no feature on demand keys? Absolutely not. So how that works is each one of those has its own SI, or has its own feature on demand licensing scheme, and activates your A, B, and C ports as well as some additional external ports, whether it's 10 gig or 40 gig for uplinks. Okay, and we'll be talking about those a little bit in detail as moving forward through the slide. The specific need offerings on the right are if we have a customer that is a diehard Cisco and they typically don't allow anything other than that in the network, for instance, we have the option to go with the B22. Now, there are limitations there. It only has 22 ports of 10 gig. It only has the capability of the A-side ports and up to 8 10 gig ports externally. Okay, and that would be managed by either a 5K or 6K device upstream for a top of rack. All right, then we have the EN4091, which is essentially nothing more than a straight pass-through device. Okay, no firmware, nothing to do with there. It's a straight pass-through. It's not really a problem, but the issue there is that for every node that you have, if you're going to have 2 of these, you have to have dedicated uplinks. So it does take quite a bit of cabling and external port connectivity in order to get connectivity into all of the nodes within a single chassis. All right, so from there we have the brocade switch, the EN4023, which is a 10 gig scalable switch. And that does have the ability to offer the fabric-like capability up to a brocade switch. So if you're a brocade diehard fan and you have the brocade top of racks and you have that option for the fabric connectivity from brocade, you can connect that into their fabric, much like what I was just referring to from the FlexSI fabric standpoint. Okay. And then lastly, we have the EN6131, which is an all 40 gig Ethernet switch from Mullinex, and that's 40 gig externally and 40 gig internally, and that's really for high, extreme HPC types of environments that want to go with a kind of a blade kind of architecture. All right, so just a little bit about each one of these devices. The first one is the SI4093 and the EN4093. Because we put these on the same slide, well, the reason we put these on the same slides, rather, is because really, like I kind of mentioned before, it really is the same switch. It's just the SI has a subset of the features. It doesn't support spanning tree. It doesn't support VLAG. So there's lots of things that it doesn't support. It's a straight layer 2 switching pass-through device that you can also, if you will, or if you wish, you can also put into VLAN aware mode as well. So it does come with some different options there. But again, some of the characteristics of the devices or the SI4093 are not there, like VLAG, VLAG layer 3 routing, if you will, and some of the other options. And then the EN4093 does offer all that capability from layer 2 to layer 3 to VLAG capability, stacking capability, and so forth. So there are value props to both. Okay, ease of connectivity. The EN4093 again does support the ability to support Easy Connect for a transparent approach. And then if you look at the bottom there, you have your different port offerings based on the feature-on-demand licensing scheme. Okay, the base switch or the base switch, without any of the feature-on-demand upgrade options enabled, does provide for 14 10 gig internal ports from each of the devices, and up to 10 gig uplinks. Okay, by default with the base system, you don't get any of the 40 gig uplinks enabled. But as you grow, and if you would like to increase the bandwidth availability to the nodes or even upstream for that matter, you can add additional upgrade options. All right, so the EN4093 is similar to the EN4093, only it also offers up to 8 what we call Omni Ports. An Omni Port has the capability of acting in either 10 gig or straight 4 or 8 gig fiber channel. Okay, so they can be converted. By default, those Omni Ports come standard in 10 gig mode. There is no key license required in order to enable the Omni Ports, so that, or rather the FC capability from those Omni Ports. And that's really the biggest difference. Again, This device here allows for both NTV mode as well as full fabric mode. So you can do your zoning for maybe an office type of location or remote office type location. You can offer the zoning right on these devices. So you don't need an actual fabric switch externally. All right. Flex EN 2092. This is the last in-house switch that we'll talk about in detail. This one is the 1 gig scalable switch that offers, again, up to 48 ports with the ability to do the feature-on-demand options. The base switch is 14 1 gig and 10 1 gig externally. Okay, so it's 14 1 gig to the servers, and up to 10 of the 1 gig external ports are enabled with the base system. And then you can grow. If you need more than that, you can always grow using the feature-on-demand upgrade option 1 or option 2. Okay, and then just a little bit about the Ethernet offerings, and then I'll talk about the rack switch portfolio after this. So the Ethernet offerings, the EN4091 10 gig, again, well, not necessarily again, but offers 14 10 gig downlinks and 14 1/10 gig uplinks. Okay, and what that is it's auto sensing. So if you've got a 1 gig switch external and you're connecting in via a 1 gig transceiver, if you will, the 1 gig has to be enabled on the server. Okay, the default line card does support both 1 gig and 10 gig, so it is auto sensing. So and it auto senses based on the type of port that you connect to the upstream device. All right. Moving to the right, the Cisco B22 fabric extender. It has requirements for 2-port connectivity to the node. Okay, if you only require 2 ports, and again, if you're a Cisco diehard and that's the only thing the network administration will allow into the network, then this is an option. And it requires to be connected to either a 5K, and this, the 5548, 5596, or one of the 6K options, which will be provided for management. And that's where those devices would be managed from. Okay. The N4023 10 gig scalable switch, again, the base is 10 gig downlink, or I'm sorry, up to 14 10 gig downlinks, up to 10 gig uplinks with 0 to 40 gig uplinks enabled with the base system, and then you can grow into the 40 gig uplinks or additional 10 gig uplinks if you wish. It has the same number of 10 gig options or 10 gig ports that the in-house switches have, in this case, which will be the 64 ports of 10 gig. All right, then the last one here is the 6131 by Molex, the 40 gig all switch, the all 40 gig switch, only has the capability of running in 40 gig mode. Okay, so it doesn't have any all sensing capability. Okay. All right, so real quick, let's talk about the rack switch portfolio. We have 2 different series of choices. We have the 7K choice, and then we have the 8K choice. The biggest difference is that the 7K choice is it's an entry, low cost. It's not necessarily feature rich, but it offers only layer 2 features only. VLAN spanning tree, all that stuff. The CLIs are identical, okay, but it does offer only layer 2 only. It doesn't have any layer 3 capability. It only has a single power supply with the base switch, but does offer the ability to grow or the ability for an external backup power supply. And again, it's for low entry level pricing. All right, the G8000 series offers redundant, out of the box, offers redundant fans and redundant power supplies, feature-rich layer 2 and layer 3 connectivity, hot swap support for both the fans and the power supplies, has an investment protection for the plan's OS feature enhancements, and cloud-ready features such as OpenFlow and VXLAN. Now, OpenFlow is only offered on the 10 gig switches, so if we're talking about the 8052 or the 8000, OpenFlow would not be offered on those. And VXLAN is only offered on the 8332 because it has to be supported in the ASIC. And currently, the only ASIC available in our portfolio is that supports the XLAN is the Broadcom Trident 2 ASIC. Okay. You also have a choice on the 8000 for a front to rear or a rear to front airflow. Okay. So a little bit deeper in the 7K family, we have two different products, the G7028 and the G7052. Now, where I've seen these being deployed are really for management only environments, whether you have an enterprise environment where you need only management from layer 2, not really too concerned with the additional power supply, and you need something that's low cost, maybe for HFT, HPC environments, again, enterprise, or even wiring closets that don't have requirements for PoE. Okay. Let's see. Moving on. So this is the 8000. You can see that it's widely vast over that of the 7K series, right? We only had two products in the 7K, the 7028 and 7052. If you move back, though, one thing I did want to note that both of these devices have management capability, out-of-band management capability, as well as up to 410 gigs for uplinks. Even on the 7028, you can use those uplinks of 10 gig. You can also use them as 1 gig SFPs if you wish. So they're not necessarily all sensing. It really depends on what transceiver you plug into those. And any of the 10 gig or 40 gig products will support any vendor DAC cables as long as you adhere to the lengths that we support. Okay, so let's talk about a little bit about the 8000 series family. So we have our flavor of 1/10 gig switches, in this case the G8000, the G8052, which is really its predecessor, and then the G8124E is the all 10 gig switch. So if we focus on the 1/10 gig switch, again, those are really for management. However, because of the fact that they are based on, well, at least the G8052 anyway, is based on the single ASIC technology, it does have pretty high, pretty nice bandwidth and latency characteristics. Now, would I say that would this be something that you might want to put in a 1 gig HPC environment? Probably not. You definitely want to go with either a 10 gig ultra low latency device, but it does have the capability of doing layer 2, layer 3, as well as VLAN. Okay, so you can put these into a virtual chassis, or you can put two of these in a virtual chassis configuration. Okay, all of these, matter of fact, except for the G8000, supports VLAG. Okay, the virtual link aggregation. Now, I talk a lot about VLAG is because if you're familiar with VPC or the MC lag that the other vendors may refer to it as, it's really an enterprise solution in order to virtualize a couple of switches at top of rack to provide a full active-active redundant environment. Okay. All right, so talking about the 10/40 gigs, we have several different options there. If you look at the one on the left, the G8264, it's 48 ports of 10 gig SFP+, capable of using either DACs or the transceivers, and supports up to 4 40 gig QSFP+ ports. Again, you can use either the MCP DAC, the MCP fiber transceiver, or some DAC cables. Low latency, 880 nanoseconds on the 8264. Hot swap power and fan, and has the ability to stack. Okay, the G8264T provides 48 ports of fixed RJ45 connections. Okay, so that would be using Cat6 cables in order to connect to servers that also might be running 10 gig base T connectivity. All right, and then it also supports up to 4 of the QSFP plus ports on the left there, again using either DACs or transceivers. The next one is the G8264CS. This is the device that we use in the Fabric SI, or the Flex SI Fabric solution, which I'll be demoing here in a minute. But this is a 10/40 gig switch that provides 48 ports of 10 gig, and out of those 48 ports of 10 gig, you can have up to 12 Omni Ports. Those Omni Ports can be configured for either 10 gig natively or 4/8 gig fiber channel. Okay? Now, if I may back up a little bit, I think the CN4093, when I was referring to that, which is inside the chassis, and it's equivalent to this 8264CS, I think I mentioned that it only supported 8 Omni Ports. Well, that was incorrect. It does. Both of these products supports up to 12 Omni Ports. So I apologize for that. Misnoting of the number of Omni Ports. All right, and it supports up to 4 of the 40 gig QSFP plus ports. The next one is the all 40 gig switch. The first one that we provided in an all 40 gig form factor was the JA316. Supports up to 16 QSFP plus ports with low latencies of under a microsecond. Hot swap, redundant, and power supplant. I think I've noted that. Every one of these devices supports hot swap except for the first one there, the G8000. It is redundant, but it's not hot swappable. It's a fixed power and fixed fan option. Okay. All of the other ones in this portfolio or on this slide provides for hot swap, both power and fan options. And then here's the newest member of the portfolio is the G8332. Again, 32 ports of 40 gig QSFP plus. Most of the ports, not all of them, most of the ports can be configured for 10 gig connectivity. So you can use breakout cables in most of the ports. And I say most because there are some limitations. If you actually did the math, it would break out more than the physical 10 gig characteristics of the ASIC can support. So only a subset of the 40 gig ports on the 8332 can be broken out into 10 gig mode. And this is also the device that supports the VXLAN gateway capability. That is not available today. We're looking right now at Q2 2015 for that VXLAN gateway capability. All right. So that's it. So let's go ahead and talk a little bit about. Let's go ahead and get into the questions a little bit, and then I'm going to be transitioning over to the live demo. So let me exit from here and bring up the. Ben, where are the questions located?
Yeah, it appears there's one question from Christian. He says, just as an example, can you quantify the amount of bandwidth that is saved by it staying in the chassis rather than going outside the chassis? Essentially, how does it translate into performance in real world? I assume we're talking microseconds.
So right. So all of our in-house 10/40 gig switches are based on the Trident Plus ASIC, and by that ASIC, we're looking at about 550 nanoseconds from port to port. Okay. So if you cross 2 ports, then you would double, or 2 switches rather, like across the VLAN option or across the VLAN, then you would encounter a 2 hop in doubling the latency time. But if you're going from node to node within the same embedded switch inside the Flex chassis, then you're only looking at about 550 nanoseconds. So it's literally sub 600 nanoseconds from port to port on any of those ports.
All right, great. Looks like that was the only question we had so far. I'll let you know if any others pop up.
Okay, great. All right, so let's go ahead and transition a little bit. So I'm sharing my entire screen. But what I want to okay, so this is the Flex SI Fabric setup. So the one that we have currently set up in the demo is this one here, where we have essentially two of the 8264CSs connecting to two of the core switches. These cores in the demo are the 8264 switches, okay? And they're running not BCC, but they're running VLAG, right? And then we have two chassis, and in the demo we have chassis 1 with two of the SI4093s and a chassis 2, but only has connectivity to one of the SIs. Not sure what happened to the other one, but for whatever reason it's MIA. Okay, so getting into the demo a little bit. So I'm going through a jump server, and I'm going to be launching the Flex Fabric master here. Okay, and then I'm going to refresh the screen a little bit, and I'll log in through by default admin, and you can see already that because of the greater sign there, and then the pound sign after going to an enable mode, it's similar to what you might be familiar with if you're familiar with the Cisco CLI. And that's basically exactly what we're looking at here. So this has already been built out. So if I do just a quick show run, these are the fabric switches, and you can see they're all named. I've got a primary fabric controller. I've got a secondary fabric controller, and those specifically are the 8264CSs. And then underneath that, I have the SI4093s, and I have three of those. So this is basically SI4093-1 and chassis 1. So you can see chassis 1, switch 1 there. The second one is chassis 1, switch 2. So that would be the second SI4093. And then the third one would be in chassis 2, switch 1. And again, the other one is MIA, missing in action.
Scott, sorry to interrupt. Is there any way that you can make the font larger?
Yeah, absolutely. Let me Control 14. There. Is that better?
Perfect, thanks.
Okay, great. Okay, so to continue on, what we have here is that the CN4093s are also running in both Ethernet and fiber channel mode. And so what we've done is if you look at this, if it's a 1 colon, that would be the first top of rack 8264CS. If it's a 2 colon, that's the second CN4093, G8264CS switch. So 1 colon, we have of the Omni Ports, we have 153 and 154 converted into fiber channel, converted into or changed into the mode, changed to fiber channel mode. Then on the second G8264CS, we have the 2:53 and 2:54. Now you can see, and I'll do a show of VLAN in a minute, but you can see that on the first G8264CS, we're running an actual fabric of 1001 VLAN. And on the second G8264CS, this is connecting to the fabric B on VLAN 1002. Okay? And I'll get into that in a little bit more. But so this is the system notice, and then underneath that we start with the ports, right? So these are the uplinks. So the 1.1, if you know our port nomenclature, the port 1 in 40 gig mode is the first QSFP plus port, and that currently is connected to the top of rack 8264 pair of switches running VLAN. Right? So we've got 1.1 and 1.5. 1.1 is connecting to one of the 8264s, and 1.5 would be connecting to the other 8264 switch. And of course, these are in a single port channel, and I'll get into that in a minute. 1.9, so 2, and then we have 2.1, 2.5, and 2.9. Don't worry about 2.9 or 1.9; those aren't in use. The 2.1 and 2.5 are the second G8264CS, the backup, and those are connecting to the uplink. And then you get into anything with a 3 or after are the SI4093s, and you can see that we've made this fairly simple in the sense that basically by giving it a description, chassis 1, switch 1, the first SI4093, that's an INTA1 port, which means it's the first port on the node in that chassis. And then we just go on the line. So it's INTA1, A2, A3, A4, so forth and so on. And then we have a switch port mode trunk, switch port trunk allow VLAN, and those are all the VLANs that are allowed on that trunk. So there's your FCE VLAN, and then these would be the production VLANs. Okay? So we scroll down, and we see that the 3 colon, and then we have a 4 colon, again, the INTA ports, and then a 5 colon. Now, if you haven't added the switch, it won't show up in the config, which is pretty significant in the sense that because we support up to 18 of the SI4093s, we didn't want to show anything that wasn't currently involved in the fabric. Okay. Now, here's the VLAN configuration. Basically, there is no enable command. We're essentially, as you can probably note here, we're essentially trying to move further and further into a more standardized CLI that's really based off of maybe a Cisco Nexus or an iOS type of device. These are our LACP, which is basically a way to aggregate your ports. So we're creating an LACP key, 1000 on all 4 of those, and you can see that 1115 and 21 and 25, even though they're on different switches, it's a single virtual port channel connecting to the upstream environment. All right, so we have F2 gets enabled, CE enabled. There's our management IP and then the management flow. Now, if I can do a show run type section IT, what this does is it will provide the information in your fabric. So you can do it. So you can look at the fabric switch number 1 description as the primary fabric controller. Now, don't get confused with fabric. That doesn't mean FC or fiber channel. It's the fabric is part of the Flex SI fabric, okay, that we've been referring to. This is your secondary, which is the other G8264CS, and then these are your SIs, the chassis 1, switch 1, chassis 1, switch 2, and chassis 2, switch 1. Okay, and that's pretty much what
before you leave the screen, there was one question that came in. Is there a way to alias the port names to something more descriptive?
Absolutely. So if you don't like the internal ports, so if we do a show run real quick again, so you see how I provided aliases. Oh, if you're talking about this alias, no, but you can give them port descriptions, and what will happen is when you give them a port description here, any of your show commands will now show the description versus the actual alias name. So for instance, if you do a show int status, you can see that instead of using the alias port number, it'll actually use the name of the description. Okay. Now, once you get into, so remember 1 colon and 2 colon are the top of racks, and then so I actually named all these chassis 1, switch 1, all the way down, and then you can actually look to see that chassis 1, switch 1, INTA1 is the physical virtual fabric port ID of 257, which you really don't have to care about, and you probably never end up using. But that will identify this port when you're running a command as INTA1 and chassis 1, switch 1. It would be connecting to your first node in that chassis.
Okay, perfect.
Okay, so it does take a little bit to get used to, but it's a very simple setup. Essentially, once you start adding additionals, all you have to do, which we do in config T mode, fabric. If you do a fabric bind, once you do the fabric bind, it automatically binds the new SI4093 that you physically plugged into the fabric ports. And once you issue that command, any known fabric device that you plugged in, the ports will be removed from what we refer to as a black hole VLAN or a black hole port into the fabric port. Once you issue that fabric bind, at that point, all you have to do is define the internal VLAN, the internal INT ports, and assign VLANs to those ports, and you're done. That's how easy it is. I mean, I'm pretty motivated about this setup because it is so simple to set up. Once you get the environment set up, once you get the 8264s configured like this, and again, we have scripts that we can apply or we can provide you with. And what I did is I basically put in this, even though we're not really utilizing a lot of it, your description here when you first log in your warning, well, it's for authorized users only, yes, but it's not in a official company work, if you will, because it's only a demo environment, right? So this is really just to simulate the fact that we can add banners, community, SNMP community strings, syslog servers. I think I passed it, which is right here. If you're logging to a syslog host, you can log up to multiple of those, provide facilities, so forth and so on. All right, one thing I did want to show, though, is that, again, this really truly is simple, but if you do a show VLAN, you can actually see the native, these are the default VLANs that are enabled by default. The black hole VLAN is enabled on every single port until you actually define that port as a fabric port or enable it for uplink. It will always be put into a black hole VLAN. And again, when you configure the uplink port channel, you can only configure a single port or a port channel using the same VLAN IDs. It will not allow you to configure more than one physical port, or one physical port channel utilizing more than a single VLAN to prevent you from creating any loops. So it helps to safeguard you and your environment. Okay. So one of the other things, just the last thing I wanted to show, was that if you look at the two VLANs here, essentially what you're looking at is you've got a Fabric A and a Fabric B for FCOE, and your Fabric A, we're basically using, those are the two external ports that connect physically to the Fabric switches upstream, and then we're using the first INT A1 through INT A14 in chassis 1, and the first INT A1 and INT A14, and the first switch of the second chassis, so that's 3 and 5. So basically, those are the odd SI4093s, or the first SI4093s in the two chassis. And then the second SI4093s in both chassis, in this case would be 2 and 4, but again, 4 is MIA. The second one would be defined for the Fabric B, and that's really it. You don't have to worry about the pathing or cross-fabric communication, because the Fabric does not allow for that type of communication to occur. And the reason for that really is because the external ports facing the Fabric are either on one VLAN or the other and not on both. And the switch will not allow you to configure more than one FCOE VLAN for an external port, okay, for an external FC port. So it really is simplistic, and it's meant to keep you, and I for that matter, safe when designing this environment or configuring this environment.
Is there a GUI interface? Is there a GUI interface for managing this environment or setting this up?
There is and there's not. So it's a two-answer question. The first one is there is no BDI per se. So in other words, you don't physically connect to the switch through a web browser. Okay. However, we have what's and I actually have it loaded here. We have and it's still labeled IBM. It will be labeled Lenovo eventually. But this is a VM that's running in the environment, and essentially is connecting into all of the, and has management capability of all of the BNC devices. I say BNC, but I mean Lenovo Networking devices, and that would be in the in-house devices. So this right here, this first one here, and I built a couple of different data center nodes, if you will. The first one is the SI Fabric environment. So if you look at this one, it's the only one, no save needed, it's the only one that has this right here, the 6.3, that is the floating address between the two JADE2 64CSs. if you do on here, if you do a show int IP, you'll note, well, actually, it's easier to do a show run type section IP. And then if you look here, this will, instead of doing like an INT A1, or sorry, an int IP1 and int IP2, which you might be used to with our products, or even identifying an IP under the VLAN, what we do is in order to set up the IP scheme for the management port, we have to use the MAC address of the top of rack device. So there's two top of racks, so there'll be two MACs identified. So this first MAC is based on the first or the primary G8264CS base MAC address that we use, and we set an IP address behind it, and this is 16.6.1 rather. And then this one is the secondary G8264CS with its physical IP address. Then we set a floater in what we refer to as a floating IP address, and this is the 6.3. Well, that's what this tool picks up on, is the floating IP address. Okay, and you can dig into this and be able to monitor its health, monitor its statistics. You can do configuration options. So you can do a device configuration. You can set configuration like for TACAX, LVP. You can provide internal VLAN, port mirroring, so forth and so on. So it allows for a full array of configuration options. And this was all picked up by the SNMP information that I set on the switch, or I set on the SI fabric environment rather. Okay. Now, even though you have layer 3, it's because the Flex SI fabric solution doesn't provide layer 3 capability. It's still listed here because these are all the actual values. It even has the ability, this tool even has the ability to not necessarily just monitor, but also define and configure your FC and FC zoning. Now, there is no, I've got to set an NTV mode, so that there will be no zoning information here. Okay, but you can look that the FC ports 53 and 58 and 182 and 181 and 182, right? You're looking at those things. What the heck are these, right? So remember what I was saying yesterday. Not yesterday. Remember what I was saying earlier that there were some the physical virtual port IDs. If I do a show int those show int trunk. Right, and we're looking at the VNet 1001 and 1002. There's 1001. Physical port is 53 and 54, right? Well, if you look at 1002, which are the uplinks on the second H2GA264CS, that's the physical port 181 and 182, and that's what this is picking up on. 53, 54, 181, and 182. You can also browse and add ports at will and so forth. But this just gives you an idea of the capability that this guy has. Now, because I'm in the SD selection, you can see that this is only displaying the Omni Ports, which are ports that are capable of being enabled with fiber channel. Okay. Let's close that. Go back to here. So that's the SI fabric. Now, just to kind of show you some other kind of factoids here is that it doesn't only manage the SI fabric, but it also manages our top of rack devices. Here we've got an GA264T. We have a G8264, we've got an 8000 and an 8052. These are the 1 gig managements, remember? This is the 8264, which is really a bread and butter top of rack device. And then this is the 8264T, which is the 10G based T switch. Looks like this one, the 8000 is currently down. But again, these have the same capabilities. If we're talking about any of the 8K series, we're talking layer 2 and layer 3. So at this point, you can configure BRP, OSPF, BGP, all of it can be done under this one utility. Now, one of the things is that it comes up with a summary. It'll actually show you what the CPU and memory utilization is in a graphical visualization, as well as the ARP and routing table, power supply, whether it has a panic dump, and then some of the temperature sensors, or actually all of the temperature sensors on these devices, and the RPM of the fans that are running inside the chassis. Okay. now we're on the Monitor tab. If you go into the Configuration tab, that would be how we basically configure the devices. But these are the absolute values for packets in, packets out. Okay, these aren't real time. These are absolute values over time. And you can see that there's an average on a per second basis that is calculated here too. And you just let it run, and it'll show over time what the actual average delay is for the from packets in and packets out on a per port basis. And then one other thing, just talking about the ports here, you can actually see that bytes in and bytes out, unicast, the type of packet, and then you can export these into different. You can export this into a CVS file. Provide different options for charts. Provide a chart on this. Well, I need to draw a chart, please. Oh, okay, so I have to select the row. So if I select that row, and then you can start, and then you just sit here and watch it. So this actually is pretty cool. It's kind of like if you're, not LDC, but if you're familiar with like S-Flow or NetFlow, this is kind of similar to that, but it's in real time. It doesn't have statistical readings. So you'd have to, I don't think there's any data on this port. That's why you're not seeing much here. But over time, you would actually see, and this would probably be more crucial for maybe uplinks or even downlinks from a troubleshooting perspective. You could utilize this just to kind of monitor each of the individual ports. And you can have multiple of these running at the same time as well. Okay. Any other questions?
Nope, no other questions have come up so far.
Okay. Well, Ben, I'll go ahead and hand it back to you. Thank you, everyone, for joining. I hope you all were able to stick around and listen to the presentation. If you have any questions, please reach out to us. We're always here. We're available. We have an entire SE support team and sales team within the U.S., North America, and worldwide for that matter. I appreciate your attendance. Thank you.
Yeah, thank you, Scott. It's been, I know I appreciate the deep dive, and I'm sure others did as well. We'll be posting this recording onto our wiki page, and I'll send out an email here within 24 hours with a link if you don't already have it. With that, we'll go ahead and close the session, and thanks, Scott, and thanks, everybody, for joining. Bye now.